Hello, and today we're going to talk about rationalising the denominator in surds. So when we talk about surds at this level, we think of numbers where it is easier to write them in the form square root of a, etc., or in terms of pi. We generally use surds to be able to simplify long mathematical equations down to their simplest form using a neat way of writing numbers. So if we had a fraction and needed to simplify it, sometimes we will need to write a surd in a different way and get a rational number in the denominator, so it cancels off with that rational number that's on the numerator. But that is for another day. That's basically for when you've got to A level and it happens more at A level. So what we need for this topic is knowledge of multiplying surds out. So if you are not sure, I will now quickly go through one of these. So what we've got here is 4 root 5 times 2 root 5. So what we do is we times the two numbers together, so that's 4 times 2, and that's the two numbers at the beginning. You think about it like 2x times 4x. You times the 2 and the 4 together, and then the x and the x together. In this case, the x's, the equivalent to those are the surds. So what we do is we, let's just see if we can do this. Not quite. So basically we times the 4 and the 2 together to get 8, and then we times the square root of 5 and the square root of 5 together. So basically square root of 5 times the square root of 5 is square root of 25, and then what we've got is the square root of 25 cancels down to 5, so it's 8 times 5, which is 40, not 200. Okay, so now what we need to do, so the method. In order to turn any surd into a rational number, or to eliminate the square root, we need to do the opposite of square root, which is squared. We need to multiply the numerator and denominator by the surd in the denominator. Okay, so it's more clear when we actually have a go at one, as usual. So, question. Rationalise the denominator of the following. So what the question would say here is 1 over square root of 3. So if we go back up to our method here, we need to change the irrational number on the bottom to a rational number. And the quickest way of doing that is to times it by itself, i.e. as squared. Okay, so basically what you do to the bottom in a fraction, you do to the top. So basically if you've got square root of 3, and not the only way of changing it into a rational number, but it's the easiest way, is to times it by itself. So what you needed to do there was you need to times square root of 3 times the square root of 3, but what you do to the bottom you also do to the top. So basically it's now 1 times the square root of 3 on the top, which is the square root of 3, and then on the bottom it's the square root of 3 times the square root of 3, which is the square root of 9. Now, it is still a surd on the bottom, but we can simplify this surd. So the square root of 9 can be simplified to 3. So therefore the square root of 3 divided by the square root of 9 simplifies to the square root of 3 over 3. Okay? And there we can see that basically the square root of 3 all squared, the squared cancels out with the square root. Part B, and this is another rationalise the denominator. So what we've got here is 5 over square root of 7. So what we've got is 5 times root 7, or 5 over root 7. So what we need to do is to times by the denominator over the denominator. So what we've got now is, so let's write that down, just okay, so we won't write that down. Okay, but basically it's 5 over root 7 times by the denominator, the denominator over the denominator. So what we've got is 5 times root 7, which is 5 root 7, and then we've got root 7 times root 7, which is root 49. And root 49 cancelled would be 7, and the top can't be simplified. Okay, so basically, in order to rationalise a basic denominator, you times it by the denominator over the denominator. So thank you for listening today, and we hope that that made Surds a little bit easier for you. And we hope to see you again very soon.